Okay, in this video we're going to be doing Calc AB Problem Set 86. The problems and a playlist are in the description below. Let's look at the problems. So we have the graph of velocity of a particle with position x equals 3 at t equals 6 is given above. Use it to answer the questions. A, when is the particle speed decreasing and we want to justify? So we know that speed is decreasing when velocity and acceleration have opposite signs. In this case, we need to look at where velocity is positive and velocity is decreasing, which would mean acceleration is negative, or where velocity is negative and increasing, right? Because that would mean that acceleration is positive. So we're looking for those regions. When you look at the graph, you can see here, here, and here. So we have velocity is positive and decreasing or negative and increasing. That's what we're looking for. So now we just have to kind of like write this down. So I'm going to say that speed is decreasing on 0 to 1 and on 10 to 12. And my reason for that there is going to be that v of t is greater than 0 and v of t is decreasing on those intervals. Then I'm also going to say from 2 to 6. And my reason there will be that v of t is less than 0 and v of t is increasing. So this whole thing is based on the fact that we know that v of t decreasing means that a of t, which is equal to v prime of t, is less than 0. And v of t increasing would mean that a of t, which is equal to v prime of t, is greater than 0. So we need velocity and acceleration to have opposite signs. And in this case, we're referring to the velocity graph and the slope of the velocity graph, right? So let's take a look at part B. Find the position of the particle at t equals 10. Okay, so we have the velocity graph. If you go back to the original question, we also know that at t equals 6, the x-coordinate is 3. So we know where we're starting. We're starting at 3. And then we just really need to figure out displacement. So displacement is going to be the signed area under the velocity graph. So we need to go from 6 to 10. So I'm trying to do start plus displacement. That's like the name of the game, right? So we want displacement from 6 to 10. And that is a triangle that is 4 by 6, which would be, well, it's a rectangle that's 4 by 6 and then half of that. So half of 24 is 12. Okay, so what we want to do is say that x of 10, the thing we're trying to find, is the starting value, which we know was 3, because that was given, plus the displacement, which we just calculated, was positive 12. So we're 12 units to the right of where we started, and we started at 3, so we're going to end up at 15. Nice problem. Let's take a look at the next part. When is the particle farthest left between 0 and 14? And we want to justify. So this, when you see it, to me, if you're looking for like an absolute max, absolute min on a closed interval, always going to be the candidates test. This is a classic example of how you would use the candidates test. So I'm going to start off with, if I want to use the candidates test, I need the function to be continuous on the interval. So I'm going to chop this up. We know these values. This is going to be 3. So maybe I should go back and explain a little more what I was doing there. I just like took the 12 from the previous part. Then we have a rectangle that is 4 by 3, so that'll also be 12. We have a triangle that is 2 by 3 by 1/2, so 3. I don't know why I keep saying that in this video, like a triangle that is 2 by 3. What does that even mean? We have a rectangle that's 2 by 3, and then we have half of it, so 3. So we get this. Then here, we're going to have, like from 0 to 1, we have a triangle with a base of 1, height of 6, so overall area is 3. Then we have another triangle that goes from 1 to 6, so that's 5, height of negative 3. That'd be negative 15, but we only get half of that. So we know all these displacements. Now we just need to use them. All right, so I need position to be continuous. So I'm just going to state that that's true because position is continuous. And therefore, our absolute minimum, which would be the farthest left that we go, right? Because we're just moving left and right, I guess, in this context. It doesn't really say that anywhere in the problem, but since it's x equals 3 when t equals 6, I'm assuming we're moving left and right. So the absolute minimum, or when you are farthest to the left, is going to be at either an endpoint or a critical point. And the reason we know that is the candidates test. So when you do the candidates test, you set up this table, right? So you have t, you have x of t, and now we need to find the values at the endpoints and the critical points. So at 0, at 1, at 6, and at 14. 1 and 6 are where the velocity is equal to 0, 0 and 14 are the endpoints. All right, we definitely know that at 6, the x-coordinate is 3. That was given. Now, we can go to the right and figure out where we are at 14 because our displacement from 6 to 14 is 12 plus 12 plus 3, so 24 plus 3 is 27. But we were already at 3, so if we move 27 to the right from 3, we'll end up at 30. Now the next part is a little tricky the first couple times you do it, but you just have to think, like, if you were moving from t equals 1 to 6, you would lose 7.5, right? Because the displacement on 1 to 6 is negative 7.5. So if you go backwards from 6 to 1, you will gain 7.5. So if you were at 3 at 6 and you gain 7.5 by kind of like rewinding to 1, you're going to end up at 10.5. And then you use the same logic to figure out where you are at 0. If you went from 0 to 1, you would gain 3. So if you go from 1 to 0, you will lose 3. So if you start at 10.5 and you lose 3, you're going to end up at 7.5. Now, in this table is the absolute minimum and the absolute maximum. We know the absolute max is 30. That's not the question. The absolute minimum is the question. So we can definitely say that we are farthest left at t equals 6, and the position at that time is x equals 3. That's a really good candidates test question. I don't feel like I'm doing a good job of talking in this video, but hopefully the math is making sense. All right, let's take a look at the next one. We want to evaluate the integral of x cubed plus 3x squared minus 5x plus 4 all over x minus 2 dx. This is an improper fraction, so we have to do division. So you always need the degree of the numerator to be less than the degree of the denominator before you actually do an integral. So let's divide. I'm going to do synthetic, so we put 2 in the box. Then you got 1, 3, negative 5, and 4. Bring down the 1, multiply, add down, multiply, add down, multiply, add down. All right, now the whole premise is that we can rewrite the original integrand as, so since we started x cubed with the original, it'll be x squared plus 5x plus 5. And then our remainder, which is 14 over x minus 2. So our integral becomes this. And this we can just reverse the power rule 3 times. And then that is a natural log. So we'll have 1/3 x cubed plus 5/2 x squared plus 5x plus 14 natural log absolute value x minus 2 and then plus c. All right, and we got one more problem in this problem set. Let's take a look. We want to find dy dx for x cubed y squared minus sine of y equals 0. So this is implicit differentiation. So step 1 is to find d dx of both sides. So I'm just going to write that down. D dx of both sides. The left-hand side is where like all the action is on this one. So we have x cubed y squared. That's going to be a product rule. So we're going to do first, derivative of the second is 2y dy dx, plus second, which is y squared, derivative of the first is 3x squared. All right, and then we need the derivative of negative sine of y. Remember, the derivative of y is dy dx, so this is still a chain rule type problem. So it's going to be negative cosine of y times the derivative of y, which is dy dx, and then that's going to equal 0. So now what we're going to do is we're going to take everything that doesn't have a dy dx and move it to the right-hand side, which will give us negative 3x squared y squared, and then we will divide by the coefficients of, so let me just start writing it. So we're taking the 3x squared y squared moving over, so that's negative 3x squared y squared, and then divide by the coefficients of dy dx, which is 2x squared y minus cosine y. All right, and we've been doing implicit for a long time now, so hopefully that's like a nice little review question in the middle. Anyway, that's the whole problem set. I hope this was helpful, and good luck.